So let's start our discussion on Python. So we'll start from there. In the last session, we left our class once we were discussing about what a program is. So about the program, I said program is nothing but a sequence of steps. A sequence of steps. That steps have definitions and commands. That's how I define a program. Okay, and then I said definitions, they involve creating of functions, classes, variables that we are going to learn and I think probably in today's class and next class. And then how is this program executed? Now I'd like to show you the execution of the program. Execution of the program. Okay. Do stop me if you have any questions, because I would love to take your opinion on these things. So how is this program executed? I'll just give a high level overview. So what we have, whatever you write, we write the code in what's called as high level language. What I defined this high level language is, I said that this language is somewhat closer to humans. Humans do understand it better than machines. So this is called as source code. Okay, whatever program you wrote, let's suppose you took a language C, or you took a language Python or C++, you wrote some commands for that, you wrote a program in that. Okay, so that program is called as source code. Okay, after that I told you that it needs to get translated. So okay, there's a step of translation involved. Okay, I'll just make a box of translation over here. So here we'll translate the program. Why do we need translate? Because you know that machines only understand machine level code. So here this translator would convert into what's called as machine code. Okay, once we have this machine code, then we basically have a running program. So from this we get a running program, an executable file which is executed. That's why in Windows you see that extension exe. Exe means executable, it will execute. So then you have this executable program. I'll write executable program. Probably if a guy knows computer science, probably he'll laugh at the explanation, but there's a very high level explanation. Each of the step in itself is a huge, not even just a topic, it's a research field in itself. This translations, how to make these languages, what is this machine code, and even this is also machine dependent. This code is machine dependent. It depends on the machine, what machine you are doing coding on. Okay, so here we now give the input, and this will give us the output, and this is our translation. Okay, coming back again, we have the source code, high level language in which you wrote the code. Basically what code is, a program you will write that will be full of some definitions. Definitions include functions, variables, instructions, and then these commands are there, definitions and commands. And once we have that, and then we want to execute the program. Before execution, what will happen is, now you write the code in high level language. That's our source code. There is the steps of translation involved. After that, we get it converted into machine code, and this machine code is basically executable. That's what you can execute. Okay, that this takes now input and it gives some output. So this translation is language dependent. Whatever language you have based on that. So usually people, language that use, they either use compiler or they use interpreter, or they use both like Python. Okay, so what is a compiler? So let's have a brief discussion about what a compiler is, so that we'll complete the picture. What's a compiler? Compiler is nothing, it's again a program. Okay, it's a complex program. It's not simple program, it's a complex program. You know that it's required. The high level language is to be translated into the machine code. So this compiler is basically a complex program. It takes another program as an input. So this again is a program. So this is a compiler is a program. Again, it's a set of definitions and commands. So it takes input as a program. So you'll give it a program, that's what is known as source code. And from this program, it will give you the machine code. And there are a lot of steps involved. Syntax analysis, okay, lexical analysis, and after that you have code generation, code optimization. Okay, there's a backend of the compilers, front of the compilers. This is a whole research area, this compiler design. So I'm just putting it in one line. So a compiler is a complex program that takes another program as an input, probably it's a high level language, and translates it into equivalent program, that's machine code. Okay, so here if you see, you have compiler. Now how does it do it? So this high level program that the source code basically is, so which results in a machine code. So machine code can be directly executed in the machines, that you know. Okay, so here what it does is, it will check the whole program once. It will compile. This process is called as compilation. Okay, the process is called as compilation. Whenever you write Python code and you first compile it, you might have seen even in GCC. Let's suppose you wrote a C program, then you write some GCC then dot output or something like that. If you are like command line experts, there you know that first we have to compile this program. Okay, we have to build the whole thing. So even this compilation process is not just compilation. So there's a lot of steps involved. It has to it has to basically do some linking, loading, and a lot of steps involved. So I'm just abstracting these things out. Okay, this is again a discussion, huge discussion. It will require probably a semester long course to understand what is going underneath, how is it translating. But long story short, that a program is there and we have a compiler. It's nothing but a program which takes the high level source code, high level language source code as an input and gives the machine code. Okay, how does it do it? So basically it does all the steps are done for the whole code. So when, if you write, let's suppose the code, so this much is your code file. So you wrote a code like this. So it will take whole of this code and check it all at once. Check it. So let's suppose if you made a mistake over here in the code, so nothing will run. Basically, it won't compile anything. It won't change the machine code. Okay, that's why what it will first check for the syntax errors. If there is some syntax error in the whole code, if there is syntax error, you won't compile the code. Okay, then probably it will see if there is that semantic is respected. If there is a semantic error, it will throw some error. So even once it is compiled, you might know that there are something called as runtime errors. So if the code is compiled and then something happened at runtime, it will throw the error at runtime. But all in all, what it does, compiler does is, it will take the whole code at once and try to do all the steps that are involved. What are steps compiler goes through? I said lexical analysis, syntax analysis, and a lot of processes there, and it will do the whole process for the whole code at once. Okay, it won't go instruction wise. So then there is second program, known as the interpreter. Okay. Now we have high level language, they can be compiled and interpreted. Okay, interpreter is a program that simulates the computer. Okay, it simulates a computer that understands high level language. Okay, it's somewhat like a compiler, but it has different steps. Again, this is a huge topic. So what it does is, rather than translating the source code into machine code, what it does is the interpreter analyzes and executes the source code instruction by instruction. Okay, if you have this program, so let's suppose each line is here is an instruction. Let's suppose each line is an instruction. This interpreter, what it will do is, it will take this instruction, so it will try to execute it first, and it won't look what is underneath it. Okay, so it will first execute this, and then this, and if the error exists here, if there is some error, let's suppose if some error is over here, so what will happen is, if error is here, still the program will be executed till here. Okay, what compiler did is, compiler took the whole program once. Okay, it did all the steps on the whole program. But what interpreter does it takes the program instruction by instruction, and then it executes the things. Okay, if there is an error over here, so what it does is, it will only catch the error after it has ran all these instructions, after it ran all these instructions till here. If there is an error, then it will throw an error. Okay, then Python basically is an interpreter based language. Python is an interpreter based language. What I told you, I promised you that I won't just teach you Python programming, I'll teach you art of programming. So now you know that languages are of different types. The first thing is, language can be high level language, it can be a low level language like assembly or C++, or high level language close to human. The second thing that you learned is, a language can be either compiler based or interpreter based, compiler or interpreter. Okay, these are the two things now. So here you saw that what is Python? Python is nothing but a high level language. It is interpreter based. So whole of the Python is interpreter, but one step that Python uses compiler for is called as syntax analysis. So for syntax analysis, Python uses the compiler. Okay, that's why if you know these compilers and interpreters, people usually call it as an interpiler language. It's interpiler based. So probably you might not find these terms. I told you that I have a habit of inventing terms, or maybe we can call it computer or something, whatever it is. Okay, so interpreter based language is that it uses for syntax analysis. If you make a syntax mistake in the Python program, so you will see that if your first 3-4 instructions are correct, and there is some syntax mistake in the 5th instruction or 4th instruction, so then you will throw the error. The Python program will throw the error without doing anything. It won't execute these instructions also. That's a key thing to understand. Let's suppose you did something, you printed hello over here, and there is no mistake in this instruction. There is no mistake in the instruction here. There is no mistake over. But if there is syntax mistake over here, I know I told you that what syntax mistake is. Okay, syntax mistake is that if it does not follow the syntax of the language. Okay, that we saw, I think in the previous class we said there are different types of errors that can be. So if there is syntax error, so what it'll do, compiler basically uses this Python uses compiler over there, and first for the syntax analysis step it uses compiler. After that it uses interpreter. Once it is once the Python program knows there is no syntax mistake, then the interpreter is used. Okay, that's a key difference. I think most of the books get it wrong. I haven't seen a book where they write it that for the syntax analysis phase Python uses this. Okay, now we are at two steps. The first thing is we saw language can be of two types: high level language, low level language. Language can be compiler based and interpreter based. I would like to give you one more thing. So one more thing, there are two types of things. So one is called as specific purpose. So what is this? Specific purpose basically means if you create a language and it only perform one type of job. Let's suppose you created a language which is only good for web programming, or you invent a language which is only good for, let's say, Android development or something like that. Okay, that language we can call as specific purpose language. Okay, then we have other thing that's called as general purpose language. So what is general purpose? So general purpose means if you can do a lot of things, you can do web development, probably you can do system programming, you can do a lot of stuff by using that language. It's not restricted to only one thing. Okay, you are not doing only scientific computations, you are doing a lot of things by that language. So even if you see here Python is this general purpose language. Okay, it's not just handling one task, it's handling a lot of tasks together. Okay, if you see why does this Python use, the Python basically has applications in web development, machine learning, and then probably making graphical user interfaces, and then you can you have that frameworks like Django and tools like Tinker, PyQt. A lot of stuff can be done by Python. Okay, now we are at the definition. I want to create the definition of the Python, what Python is, what is the language. So if you have to develop a language, you should first see if it is a high level language or a low level language, if it's a compiler based or interpreter based. Okay, then if it's a specific purpose language or a general purpose language, and based on that you will have to give the definition. Now if I have to define Python, what Python is, so Python is basically nothing but a high level language. Okay, an interpiler based language. Interpiler based. Why interpiler based? Because first it uses for only one step, that is when it's translating, because I told you while translating a high level language into the machine code, source code into the machine code, what happens is, so there is this involvement of translation and there are a lot of steps involved. The first step is syntax analysis. You have to analyze the whole code for the syntax. For the syntax analysis, Python uses compiler. Okay, I explained that. And then for the instruction execution, it uses interpreter. So Python is a high level language. It's an interpiler based language, or you can probably see in most of the books it's written, it's an interpreter based language. And then it's a general purpose language. This is what Python is. Okay, so Python again is it's in the platform independent language. So there are platform dependent language also. So here we can have platform dependency or platform independent. So based on the platform, what is the meaning of that? Let's suppose you are working in Linux. Okay, if you write a code in Linux, you have a platform there and you have a hardware there, you have some software there. If you write some code over there and if it only runs on that machine where you wrote it, that's called as platform dependent code. But if you see Python, if you write a code in Windows machine and you took that whole Python code and you can easily run that on Linux machine. Okay, that's what this Python is. Python is platform independent code. And the best thing about Python is that it's free source. Okay, it's free and open source. It's free and open source. Basically what's meaning the open source? So open source is that where developers can contribute. Okay, you know that there are different versions of Python. The Python that we are going to learn is called as C Python. Okay, and you might be seeing, is there a Java Python also? Yes, there are. Okay, so the thing is there are a lot of versions of Python. If you just check the official documentation, the thing that we are going to learn is called as C Python. That's what mostly people use, because this is open source, so it has a lot of flavors. People have created their own language. They just change, because open source, the code is available, people can tinker with the code and they can create a new language by having the basic components are the same and then change the components as they want. Okay, that's the beauty of the language. Python is a open source and it's free language. Okay, and it's again, I said it's simple to learn, embeddable, and the best thing is it's portable also, which I said platform independent. So if you have to now define Python, I hope that you got some gist of what Python is. It's a high level language, interpile based language, general purpose language, and the best part is that it's open source. And the thing that we are going to learn is called as C Python. Okay, and you can check further documentation what CPython, what are the different versions of Python. So there are different, one version is that you have 3.12 plus 0.2 something, that's the one version, that these are versions of CPython, but different types of Python are there. So the thing that we are going to read is called as CPython. I hope that everything is clear so far regarding Python. Is it clear?
Yes.
Okay, nice. Let's now move towards the Python. Okay, now I said that each of this language have a design philosophy. The design philosophy of Python is that ease of programming. The programmer should have ease to write the code. There is nothing more important to Python than ease of coding. So if you have a C++ code, that might look scary to you, but when you come to the Python, you will feel that it's really easy. So to show the ease, you can just see like different types of printing. Okay, I would also share the screen of where I can code. So now I'll share that thing. Do tell me if it's visible. Is it visible?
Yes.
So here, if you see over here, if you see over this part, so this part is basically a shell. Okay, this is the shell. So we'll interact it. This is called as interactive programming. So here I have an IPython notebook. If you see over here, this is called as IPython notebook. So usually what I'll do is to make you understand some concepts, I can sometimes use this shell that's over here, or I can write the code in full. Okay, IPython notebook is somewhat it is interactive also, and it is giving me the coding environment also. So what you have to do is you first have to install all of these things, and there are plenty of videos available online where you can install them, and you just search how to install this IDE, integrated development environment. What I'm using is VS Code, and people also use PyCharm. You just have to see how to install this, and you can also install Anaconda, or probably if you have if your machine is not that heavy, so you can use Miniconda. Or if you do not have a machine at all, that's all right. So what you can do is you can use the web version of Python. So there are, I think replet.com is one which gives this Python platform where you can write the code. Okay, all of these things you have to do on your own, because we are not going to touch. Okay, so now you have this idea. The first thing over here is I'll be coding in probably this IPython notebook. It's easy to write functions in here, or I can just write the code in this interactive environment. I can just interact with them, and I'll give you some. Let's suppose if I want to show some live demonstration. Let's start by doing something. If you see here, so if I want to go into this shell, I'll just write Python 3. Okay, first let's check the version of Python if I have Python installed. So this is the Python version. So it is showing some Python 3.12 if you can see over here. Python 3.12.2. So that's what we'll be working with. So there is Python 2 also, but there is a difference between Python 2 and Python 3 because people usually change a lot of functions because they feel some functionality is not justified. So let's change the functionality. And there has been problems with Python 2, and some like big blunders were there. So that's why they shifted to Python 3. And again, if they have to deprecate some packages, so they keep on incrementing these. Python version. So here what I'll be using is Python 3.12.2. So if you want your code to give the same output as mine, so please do install this version of Python 3.1.2, that you can clearly see over here. Okay, now in order to run this code in interactive mode, what I can write, I can just write Python 3. So I can write Python 3. So now you saw that this thing got changed. Okay, something came up, Python 3.13 packaged by Anaconda or something, whatever it is. Okay, I want to clear the screen. So if I have to now execute something, I told you that Python is very simple. There is an ease of programming. So if you have to print something on the screen using C, C++, or Java, so it will at least take tens of lines, if not hundreds, at least tens of lines it will take. But here you can just write print. Let's suppose then you can write hello world. Okay, I am just respecting the norm that is there. The first program should be hello world program. So if I just print it, you saw that there is hello world on the screen is printed over here. This is what I'm calling as interactive program. If I have to demonstrate something, I can interactively write something and execute it on the fly. Okay, so this is my what's called a shell. Okay, this on the right hand side is shell, this over here, and this here is IPython notebook. But usually I can convert that IPython notebook's code into the normal code, and this I'm using is called as IDE, integrated development environment. So it gives a lot of benefits because it will underline the code if there is a syntax mistake, and it will help in the code, and there are a lot of benefits of these. Now we'll delve into the programming. The first thing that I want you guys to understand is, now if you have developed a language, so there should be something, there should be some words which should have the meaning associated with it. Okay, when the English language was developed, see, so when the English language was developed, you must have some words which have predefined meanings. Let's suppose we'll call a word should be like cat. Cat has a meaning associated with it. Cat, if you see the animal, it's a description of the animal cat. So there are different animals. So when I say word cat, because it has some predefined meanings. Okay. Similarly, when you are creating a computer language, so what you do is, so for some of these words, you will give some predefined meanings. Okay. This is common to all the languages. This is not just per se for Python. That's what I said. I won't only teach you Python. We'll basically learn art of programming. If let's suppose you decided to create your own language, what are the things that you will have to take care of? Okay, these predefined words, they are called as keywords. Okay, so what is a keyword then? So in every programming language, there exists what's called as reserved words or keywords, which have like specific rules that govern their construction. Okay, so in Python programming, these reserved words are also, they're called as keywords or reserved words. So reserved words, they're called as, and they have some predefined meaning, and they play a lot crucial role, and you cannot use these as variable name, that we'll see. Okay, so there are some words which have predefined meaning. They have predefined meaning, and these are called as keywords. So there are a lot of keywords in Python. Okay, so there is a keyword like suppose if, there is keyword called as let's suppose else, and, or, a lot of keywords are there. If you want to see what are the keywords, there are, there is a package called as keyword. Okay, I'll show you that. I'll just copy the code and I'll paste it in here. Okay, so I'll just, so if you see over here, I have done import keyword and print this keyword.kw list. It will give the list of all the keywords. So if I run this cell, I'll have to set up the environment. Here you can see this. So this is all the list of the keywords: false, none, true, and, as, assert, async, await, break, class, continue, definition, delete, elif, else, except, finally, for, and these are all the keywords that you can see over here. And what each of them have a predefined meaning. So this false has a meaning. Okay, this none has a meaning associated with. This true has a meaning, and has a meaning, as a meaning. Every of these keywords has some meaning associated with, and you cannot use them as variable names and stuff like that. We'll see what a variable is, but till for now, what you should understand is that there are some words when you are developing a language, you should have some vocabulary. This is some sort of vocabulary we are developing, and then some vocabulary should have predefined meanings. That's what these keywords are. I hope that keywords are clear to everybody. Is it? So now everybody understands what keywords are. So keywords are nothing but they are these words which have special meaning associated with them. In every language there are these keywords. Now what we'll do is we'll understand how to write the Python code. Okay, the first thing is we'll see what is the best coding style. Best style. So what best style is, basically when you are writing a program, a C program or a C++ program, you can write that just in a single line. Let's suppose you wrote a C code like this. So you start from here, you write hash include, let's suppose this is your file, hash include std.h and something like that, and you wrote all the code in one line. Okay, so what I said is, I said that this Python programming language basically should give ease to the programmer. So when you are reading the code from somebody else, at the same time you should be able to read that code also. It is not that it should be unreadable. So this line will perfectly execute on the compiler. But why I said the design philosophy of Python was that it should give ease to programmers, not only in perspective of coding but also in perspective of reading the code. So that's what Python did. So there is something called as indentation. Okay, indentation comes in the coding style. That's why I said best style. So indentation means you have to leave some blank spaces. You should structure the code well. You should structuring of the code. Structuring of the code. So once you are writing the code, there should be a proper structure to that, so that everybody understands the code when it's being read. So what Python did is, so Python said, okay, my design philosophy is that I have to make the programming easy for designers and for the people who want to learn programming. So if a person is coding, he should have ease of coding, but if a person is reading the code, he should also have the ease of reading. So for that, Python forced this indentation. This indentation is not necessary in C, C++, Java. You can write the code in the single line and it will perfectly run. But once you come to Python, so what you have to do, you have to indent your code. Okay, you have to indent your code. But by indentation, I mean that you have to add these white spaces or maybe tabs. So unlike other programming, so where indentation is purely for the aesthetic purposes. So in C or C++, so indentation is not necessary. So indentation is not necessary. But in Python, this is somewhat compulsion. People have enforced this. This is mandatory, and that's why, because we have to comprehend the code, understand design philosophy. The design philosophy is to make this programming as easy as possible for the reading also, for the coding also. So that's why there is an indentation should be there. Okay. So let's suppose what I'll do is I'll just paste a code, and I'll show you what I mean by indentation. Going back to the coding window, if you see that, so here I'm going back to the coding window. So now I'll paste some code over there. So I'll say what indentation means. So if you see over here, I have defined something. Don't look at this def word, but if you see, I have left some of the lines over here. Some of these spaces I have left. So if I write something like this, okay. So you see that there is something red came over here because my ID is saying that this is somewhat error. So I am being forced to indent the code. So I have to press even a tab or give 4 spaces. Okay. So let's suppose if I do this, again you will see that, and you will see the error. Expected indent. This basically means you should indent the block. Indentation, you should not write it. This code is not acceptable. Now if I just write it like this, so now you see no errors. So if you see x is equal 10, we'll go to the details of the code, but just understand over here, if I just did some mistake, okay, if I did not perfectly indent it, I am getting this error. So this is the first error, and this is where I should say welcome to programming, because you will get a lot of errors. You will get humongous amount of errors when you're coding. So if you do not get an error, that time probably you will have to worry about the code. Probably your code is not good because it's not giving errors. So every day when you will code, the program will throw the errors. So the first error you saw that is expected indent in block, that you have to have the indentation over here. Similar, if I write something like this, okay, you see this again, there is a problem with the indentation. Again, the same error will come. So this forces me to indent. So what is indentation? Indentation basically is not here for only aesthetic purposes. It is here and it is enforced on the developer so that he writes better code. I hope that this indentation is clear. So if I now run this code, you can see I just need to call this function now. So if I call this function over here, don't worry about what function calling is, we'll see that. Now that you saw what this code has been executed. This is an indent block. First it printed this thing, and then as the x was 10, I was just checking for the condition if x is greater than 9 and print these two things, and now you saw that these three things are printed. This is indented properly, this is within a nested block, this is still within an outer block. Okay, is the indentation clear? For how many people is this indentation clear? Okay, so indentation in Python is basically, it is enforced. It's not for just for the aesthetic purposes, it is enforced. I have to switch multiple screens. So now we are reading coding style. So coding style, in this coding style, the first thing that we saw is in Python the indentation is forced, but if you are coding in C, C++, you should also indent there. Okay, the first thing that you saw is indentation. The second thing is you should comment the code. Commenting, this is very necessary, because what I said is you will write code once and read it multiple times. And you'll be working with teams where they have to read your code. I have seen coders who are very brilliant coders, but the problem is they don't have good coding style. That's why it is being taught now as a subject in software engineering. They say what the good practice in the code. So it's better once you learn the programming, you should have this better style of coding. Okay, the first thing that you saw is indentation. That's forced by Python, and this commenting is not forced by Python. It's all right if you don't comment the code. Okay, and there was no point in forcing this, because if this was forced, you must comment the code, then you will have to even comment a single line. Okay, and we have to make design choices. We have to make design choices now. So design choice, when the inventors of Python were designing it, they said, okay, indentation necessary, we can force this indentation. But commenting, if we forced it, then for execution of a single step, we must write a comment. So it becomes a heavy problem. So then the design choice was not to force this commenting, but they gave different types of commenting. Okay, what is a comment? Basically, a comment is nothing but just an explanation of your code, or you can write anything. It may not be the explanation. Okay, so comments are essential aspects, so they're really essential. So I'll write essential in coding, because you have to remember this mantra. The mantra is that you write the code once and read it multiple times. You'll be working with a team where they'll have to read your code. If your code is readable, not just machine readable, it should be human readable. So in there, you'll have to write these comments. Now you can comment. The Python code can be commented in multiple ways. Okay, there are different types of comments. Okay, types of comments. Okay, what are types of comments are? So the first thing is, again, this is a programming concept. Commenting a code, coding style, it's a programming. It's not just specified with the Python. Then we're seeing how Python handles it. Okay, Python has different mechanisms of handling these things, but it applies to all the programming. So even if you are programming in C, C++, Java, whatever programming language you choose, but the whole point is you must document your code. Okay, that this is called as documentation. Documentation is rather like a whole term, because what you do when you write a code or you write a huge code base and you write these separate things. Okay, so you write whole of these documentation separate. Let's suppose you wrote a function, you want to explain the functionality of the code, and in that you wrote the whole documentation. So this is just a small thing in documentation, this commenting your code. Okay, that's one thing in the documentation. So what are different types of comments now? The first comment that you have is called as single line comment. So in single line comment, what you do is you write a code. Let's suppose you did something. You have a variable called as, let's suppose x is equal to 42 or something like that. This. Okay. So then you want to see what this variable is about. Okay, and you can just comment this code. How do we comment in Python? You just write hash and then you write your comment. Let's suppose we go to coding environment to show you this. So here if you see, in this I can write x is equal to. So this will perfectly run. These comments will be ignored. They should be ignored by the compiler or interpreter. So here what we do is we'll write hash and then we'll write the comment over here. So we can say this is a single line comment. Okay, when you run this, you can see that x is equal to nothing got printed, because if I just remove this hash, now there will be an error, because now interpreter thinks that this is an instruction or a command to run, but actually this is not a command, and that this word makes no sense. So if you see, there will be some error, invalid syntax, because in the syntax analysis phase, this gave an error. So now you can just put an hash over here to run this. Let me pause. So it is explaining the single line comment. So in the single line comment, what I said is there you put a hash. If you just remove this hash, and you can put multiple hash, it doesn't make any difference now. Okay, so this hash, you put one hash, and it says that for the this interpreter or maybe interpreter, this is just this hash is the instruction that do not read this as an instruction. Just ignore this file, ignore this whole line of the code. That's why it's called a single line. But if you just move on to the second line, now it will consider this as an instruction. So let's suppose I wrote hello over here. I also wanted to comment this out, but the problem here was I somehow missed this hash, because now for this hash, this only includes for this single line. If I just run it, it'll again show the syntax error. The hello is not defined basically. Okay. Now if I want multi-line comment, what I can do is I can again put hash over here. Okay. Now this is one way of multi-line commenting. But Python, what is giving? Python is basically giving you different way to have a multi-line comment. So in that, what we do is we have 3 quotes. So this is how we'll put the multi-line comment. So let's suppose we wrote something, we wrote a whole code, we wrote a whole bunch of code over here, and then we want to comment out this code. So you can put these 3 quotes over here and 3 quotes over here, and then you can write anything, any comment in between. Okay, so I'll just show you the multi-line comment. Let's suppose you are defining a function, and then you want to, let's suppose this is the function that you want to define, and you want to say, let's suppose definition of a function, and now you want to see what this function does. So what you can do is you can just comment something like this. Okay, so here if you see that I have these 3 quotes, and I said alternately you can use double quotes as docstring. This is called, they're called docstrings when you write them in the functions. Okay, so this is usually how do we do multi-line commenting. So you should put these multi-line comments. Usually if you see a huge code base, in each of the function, if a function is large, so they write they are called as docstrings. Okay, so these things are called as docstrings. This over here is called a docstring. So if it is written within the function, okay, otherwise you can just treat it as a multi-line comment. So if you want to have a multi-line comment, just have these use these triple quotes or maybe double quotes over here. Okay, I hope that this makes sense. Now if I run this, you can see that it clearly runs. This is just for the purpose of the programmer who wants to read it. Okay, and there are different function calls where you can print this doc string also. Okay, you can just call the function and print the doc string. That we'll see, I think, in the subsequent sessions. So, but here I want to show you that there are different ways to document your code. The first set is that if you have to write a short comment, you can use a single line comment. If you want to have a lot of details, and because your function might be too complex and you want to write this multi-line comment. So this is what multi-line comments is. So these are the two things we studied in this coding style. So in coding style, the important thing that we studied is first is indentation and then documentation. Documentation. So in the documentation, what you said is we can comment the code and there are single line comments. People here who might be coding since 2-3 years or 4-5 years, so they might be pissed off, but it's all right because they are undergrad people who want to learn all of this. And then we have what is called as multi-line comments. Multi-line comments. Okay, so here we said in function it's also called as doc string. Okay, documentation string. So when you write something, you write a documentation to that. Okay, so let's suppose I'll just show you one doc string. If I write a function and then I want to get hang of the doc string, you can just write it like this. So if I'm again going to the coding environment and showing you there, so over here if I just paste it like this, I have not copied the right code. Now if you want to see that I have added numbers, so here I have written a whole detail. So this function takes two numbers as input and returns their sum. Then parameters are this a and b. So a is of type integer, the first, this is the first, this is the second number, and then the return type is also an integer. So I have given the whole details over here. Okay, and you can access the doc string also by using different commands. I hope that this is clear, and please have a habit of commenting out your code. So whenever you are doing something, write these multiple lines. But I have seen people like when they started, they'll overwrite these comments. You should not do also this. You should not have a humongous number of comments written. Which things are the things which are clear, you need not write the comments for them. But the things which are not clear, you should have a habit of writing that, but you should have you should keep the balance, which things to write and which things not to write, and you should know the balance. But it is highly encouraging that you should first start with this commenting. Okay, and if you define a function, just put a hashtag or like this hash and then write something and then write the code. And then if you feel there is a necessity that I have to explain these 3-4 lines of code, and write a multiple line comment over here. Okay, now we'll move on to what is called as identifiers. Okay, now slowly we are building the language. Now you saw there is coding style, you'll have to respect indentation, you'll have to write comments. That's for the coding style, purely for the coding purposes. But here in the Python, the indentation is sort of enforced. You cannot escape that. If you don't indent the code, it'll throw an error. And then comments, they're optional, but I highly encourage when you write the code, you should comment. Now we'll move on to identifiers. Now what these identifiers are, as you know that the name itself, it identifies something. Okay, it identifies something. I said that you have to write these definitions. I said, what is a program? Program is just a bunch of definitions and commands. Now these definitions, you'll have to use some lingo. You'll have to use something to represent these things. As in the English language, we have this alphabet A, B, C, D. So similarly, we have to write these identifiers. The identifiers can be of many types. They can be classes. Okay, we'll see what classes are. They can be functions. We'll also read in detail what functions are, or maybe variable names, or things like that. Okay, so identifier is basically a name that is given to these entities. Okay, it's a name given to the entities. Okay, what entities can be? They can be classes, they can be functions, they can be variables, or something else. Okay, now the thing is there are rules to write these. Okay, many of these people skip this. So even in the C there are rules to write these identifiers. Okay, when sometimes I have seen people struggling. There is a code is throwing an error. The problem is that they haven't respected the rules of identifiers. So now you have to name something. You have to name a function. You have to name a class. You have to name a variable. So what should you do? You should name it. Okay. Again, the coding style. The best coding style is to have a good name. Okay. You should not have x is equal 10. Okay. What this x says? It does not say anything. You should rather have a name which specifies some to the programmer. You can say first number, F number, okay, or maybe second number, something like this. You can name variables like this, or classes, class name. They should be definitive, so they should define what they are doing. So okay, that also comes under good coding style. So when you name these variables, name these classes, name these functions. So if you saw in my code when I say this function, I named the function add numbers. So I wrote something like this, definition of add numbers. So this function itself was saying that I am doing something with numbers. What I am doing is I am adding the numbers. I could have said def a. This a is perfectly valid in Python programming. This is valid in programming. But the problem is that when you are reading the code, it will give you the hard time because this name is not clear. Okay, and you will have to write the additional documentation for it. So it's better to choose really good names, to choose really good identifiers. So what are identifiers now? So identifiers are names given to these entities like classes, functions, variables. Okay. So now there are rules for these so rules to write identifiers. Okay, so what are the rules? So the first thing is that identifiers, they are combination of lowercase, uppercase, digits from 0 to underscore. So what is allowed? So you can write capital A to Z in uppercase letters, or you can use lowercase letters. Okay, or you can use 0 to 9 and you can use an underscore symbol. So when you are naming a variable, when you are naming a class or something like that, so these are the things that can be used. A combination of these letters. Maybe you can just use this, you can just use this, or a combination of all of these. Okay, so apart from that, if you use any symbol, okay, if you use any sort of symbol for the variable names, for the identifiers, the compiler will throw an error. Okay, this is the first rule. First rule I said is that, so combination of A to Z, 0 to 9, and the underscore is allowed. Except these, nothing is allowed. Let's suppose we'll go to the coding environment and we'll try to make some identifiers, and you guys should tell me whether they are valid or not, according to the first rule. Okay, let's now go here. I hope that you can see the screen. I'll sometimes use this prompt over here. Let's suppose we'll code in the shell. If I'm writing ABC is equal 10, is it perfectly valid? You can see that it threw no error. I can just print this ABC here. So ABC is equal 10. Let's suppose I wrote @ABC. Now you will see that it expects something. @ABC is equal to 10, let's suppose. So here you can see that syntax error. There's a syntax error because @ is not allowed. Even if you write ABC @ like this is equal to 15 or 10. So if I run this, you can clearly see that there is a syntax error. So okay, and if I write A, B, C, and D is equal to 10, clearly see that program runs. I hope that the first rule is clear. The first rule is that you can use uppercase A to Z, lowercase A to Z, underscore, and if I can write underscore also, ABC underscore is equal to 10. ABC, if I print ABC underscore, you can see that this is equal to 10. That's the first rule you should know about when you are creating these identifiers, when you are naming the identifiers. This is the first rule. Now coming to the second rule. The first rule, I think everybody got the hang of that. First rule is that you have to use this combination of capital A to Z, small a to Z, 0 to 9, and underscore. Now coming to the second rule. The second rule is that you cannot start with a digit. Cannot start with a digit. You cannot write something like this, one number is equal to 10. Okay, here the interpreter compiler will throw an error because this is not allowed at all. Okay, so here if you see this one number 10, if I just write it in the coding environment, just switching back to the coding screen and showing you there. So here if I write one number is equal to 10, now you see that again there is an invalid decimal, there is some error. So why it is showing this invalid decimal, I'll probably tell you in the later sessions why just showing it like this. So now you can clearly see this is throwing error. So number is this, you cannot put number in bit, you cannot put starting number, but you can write this number 1 is perfectly allowed. Number 1 is allowed, you can see that, because now I have started with this small k case A to Z. So even I can write like this, number is equal to 10, perfectly valid. But the only thing that you cannot do is you cannot start with a number. Maybe at the end you can put, at the middle you can put number 1, then number, something like this is equal to 90. So I just wanted to print this. You see that clearly it is printing the value. So now we learn the second rule. So what is the second rule? Second rule is that you cannot start the identifier with a digit. So you have to start it with underscore, or you have to start it with English letters, capital A to Z and small a to Z. And the third thing is you cannot use reserved keywords. Cannot use reserved keywords. Cannot use reserved keywords. As I showed you that there are different reserved keywords which have meaning associated with them. If, else, assert, try, catch, something like that, you cannot use them and identifier names. Okay, and the fourth thing that he said, special symbols are not allowed. So you cannot use, let's suppose, something like not exclamation at the rate that I showed you, because the only allowed symbols are these. So from this, if you now have to name anything, you should have to have this knowledge. How should I name? Naming conventions are like this: combination of A to Z, 0 to 9, and underscore. Cannot start with a digit, and then you cannot use the reserved keywords, and these special symbols cannot be used. Okay, so tell me now one thing. I'll just write some code, and I want you guys to tell me if it is valid or not. I'll start with probably Arshan. Arshan, if I write something like this, special value, I'll put it over here. Special value is equal to 10. Is it allowed? Will the code run? If it runs, what should be the output? And if it does not run, why will it not run?
It won't run because it has an exclamatory mark.
Yes, that's not allowed. So if you see over here, so if I run this, so it is showing me this error because there is this exclamation mark over here. Okay. Now I hope that you can practice a lot about this, because why are these necessary? I have seen sometimes people, they have error, and a lot of times I have seen this. People wrote one number like this. One number is equal to first number, basically. First number is equal to 10, and then they compile the whole. They wanted to execute the whole program, and it is giving the errors, and they're banging the head on their wall. Why is it not running? Why is it not running? And the problem was there because they put this one over here that you clearly saw in the rule. This is not allowed. Okay. I hope that everybody got the clarity on these rules. Can I proceed? Now in Python, what we'll be doing, so we'll be manipulating objects. Okay, I won't define the objects formally right now because we'll go on to the object-oriented paradigm. But here, everything that is in the Python, that's basically an object. So if you see whatever you write for example, A. This is A is equal to 12. So this 12 is an object. So everything that you see in the Python is basically an object. And we'll learn about this object-oriented paradigm separately. But what we have is, we have these objects, and objects have different types. So they have different types. Okay, and depending on the types, there are operations defined. Okay, with each type we have operations defined. Let's suppose if I'm talking about integer object. So with integer, there are operations defined like plus, minus, division, subtract, something like modulus, and then float division. Now all of these operations are defined. So it is somewhat like mathematics. When you have an entity, you have something, and what can you do with this? Okay, so that's what we have. We have these objects. So the first type of object that you can see is that we have numerals, and on these numerals, this is what is defined. And we'll have a detailed discussion on these also. What operations are, what these are. Now before these, let's suppose I create an object. This 12 is an integer. If I create this in the memory, so there is a memory structure like this. Okay, and we won't go into the memory structure, how the memory works. So let's suppose this is the memory where you'll keep your 12. So what Python will do is, it will allocate some memory to this 12. It will allocate some memory to this object. So this object is of type integer. Okay, if I can just in the Python shell, if I can move on to this Python shell again, so I can show you the type of this object. So it will show you the integer. That's what I'm saying. Everything that is in Python basically is an object, and each object is of specific type. Okay, all of these things will come in the details because I just wanted to explain something. Because of that, I have to introduce this. So if I move on to my coding environment again, so here object file opened. That's all right. So if you see over here, if I write, let's suppose type of 12. Okay, if I just show the type, indentation error that you can clearly see because space is there. So this is of class integer. This is basically of integer type. So if I write type of, let's suppose 12.0, so this is of type called as float. We'll see all these types. So what I said is, everything in the Python is nothing but an object. So if we have an object, and that object is of a certain type, and what is with the type, and each type basically gives you access to different operations. So you can operate on different things, and you can do different things with that object. Okay, now if you create 12, now you have to get access of these things. So convention is that you will name it somehow. So what you will do is, you should name this 12 so that you will get access to that. That's where these variables come in. Okay, so we'll define what is called as variables. So what variables basically are, in Python, variables are memory locations. So they are names to the memory locations. Okay, so if this is 12 is there, so if I want to name it, I'll name it, let's suppose x. So now X, this is how I basically refer to this 12. So 12 is sitting in the memory. Now if I want to get this 12, how I can call it? I'll give it a name. So that's what variable in computer programming is. So in computers, variables are names to these memory locations where the data is stored. So each of these variable, it's given a unique name. So that's why I said variables, they also come under these identifiers. You'll have to name the variables. If you access the memory, you'll access it by using the variables. Okay, and the rules of the naming these variables are same because it's an identifier. So rules will be here. So whatever rules we studied over here, so these are the rules. So now if I am creating 12, so let's suppose I'll say this 12 is an age of somebody. So I can create something like John. This again is an object. So it will be, let's suppose, given a name. Have this picture in the head because this will help you while you're executing the program. So here, let's suppose this can be name. So this is variable age. Again, the same thing, I can just define some more variable. Let's suppose true. True again is an object of type boolean. Okay, this will be again named by a variable. Let's suppose is valid or something. This is a variable. So all of these are variables. So they are different from the mathematics. So in the mathematics, variables, they hold the value and they can change it. So here, what the variable are? The variable basically are the names to these memory locations where these are stored. Okay, if I do something like this, if I say x is equal 12, okay, so I can print the location where this 12 is stored. I can just say there is a function called as id of x. Okay, let me show you that. So now just remember that variables are nothing but names to these memory locations. So if I go back over here, so let's suppose I'll clear this, I'll write x is equal 10. Now what should happen is, in your head, this picture should pop up that you created a variable 10, something like this. And then you named it as x. Okay, this x is basically a memory location. So if I just typed id of x, it should give me the memory location. So this is the, can you clearly see over here this number? This number over here, some 928 something. So this is not exactly the memory location, but this is the number which this is called some, there is hashing. So basically this is, you can just say it, this number over here is the location of this variable x. Okay, so let's suppose if I now create a number 12586. Okay, if I name it let's suppose some y. Okay, I'll just create over here. So y is equal some big number 123, something like this. So if I just print id of y, so now you can see that it's in the different location. Okay, this is the location and this is the location for the x. The x and y, basically they are just names to these memory locations. So id is a function which takes out the names of these memory locations. Is it clear? Is it clear?
Yes.
So here if I see, so what I can write is, I can write some x is equal to 5. Okay, so this is what I wrote, x is equal to 5. So I can write y is equal to some 10. So if I can print, let's suppose I'll print the id of x and I'll print the id of y. So why am I showing you? The first thing is, let's execute this code in our head, how this code will be executed. So if you see x is equal, so your head should be like giving some memory. So here, this is 5, this is an object of type integer, so this is named as x. So now if you have this 10, so now this will be given the value y. Okay, now this will be giving some memory location, this will be giving some memory. So now if I just print this, so you can see that these are the two memory locations. Is it clear, everybody? Yes.
Yeah, it's clear.
So what I wanted to show you, let's suppose I created an integer x is equal to, let's suppose, some 50,000. So here y is again 50,000, something like this, somewhat of 5,50,000, whatever you call it. So the picture is same. First you will create an object, something like this, whatever the number is. So this will be given to x. Okay, now while you go on the second line, we expect the same thing will be done. So we'll write 50,000 over here and then this will be given to y. Okay, now if I print these two things, so if you clearly see, if you see over here, so there, this is the address of x and this is the address of y. Okay, can you clearly see it? So what I can do is, if I write 50 over here and if I write 50 over here, I'll show you one miracle thing. Okay, here the first thing is I wrote this 50,000 and 50,000. Then you saw that these addresses, two addresses were different. Okay, then if I now run it, are you seeing that these addresses are same? Now I created two different variables. I created two different variables, but still the address of these variables is the same. How is this possible? Did you understand the thing? Did you see the thing? What is happening in here? How many of you saw the thing?
Maybe for the smaller numbers it might be same. It might be keeping until a range.
Yes.
It might be
Yeah.
the same.
That's true, because I showed you all of the things. The whole point is I want to show you the design choice. So what when the Python inventors or designers were designing the language, so what they thought is, if there are small numbers, let's put them somewhere. And this is for the code optimization, and this for probably for this memory saving of memory. So what will happen is, if you have a number 10, you create an object over here and you named it as x. Now this 10 is a pretty small number. Let's suppose you use it multiple times. This is not what C does basically. If you write C, x is equal some x2 is equal, or maybe y is equal 10 again, it will create a new, it will give it separate space. But what Python does is, for this saving of memory for these small numbers, what it does is, it will scan the memory again. Okay, so whenever you see an expression written like this, x is equal 50, so what you should do is, you should come from right to left. Okay, see the 50, make an object like this. Okay, and then name it as x. If you see y is equal 50 again, so what Python does is, Python will basically go internally and see if the 50 value 50 is somewhere. If the value 50 is somewhere, so it will just name it as y. It will have 2 pointers towards it. Okay, I said these variables basically are names to these memory locations. That's why for these smaller numbers, what Python does to save the memory, Python does it. So Python basically saves the memory. But if you go beyond a certain range, I don't know the range, that range you can check on your own. But this is the design philosophy to save the memory. So what you do basically is, you scan the memory once. So if you find these numbers somewhere, so you can just you can see that for the smaller numbers, these memory will be reused. Okay, so you can see that memory is reused over here. That's how Python works internally. So when you see this 50 got created, and then you named as x. If it was 501, okay, now it again scans the memory. It did not find 501. It will create object then. It will create this object. If it again was there, so what it will do is, it will just name it like this. It will just point it towards this. That's what I showed you this example. So when this x is equal 50, y is equal 50, you saw that this x and y was basically pointing to the same memory location. Why was that so? Because Python is designed so that it uses the less memory. But if you just increase the number, so now Python won't be able to store this number, because this is again, if you keep these big numbers, they'll use more storage. So it's better to create a new object for this. Again, don't ask me why Python people did it. Design choice. That's what designers thought. So if you now see this address or these two memory locations are quite different. But if you have these small numbers, the address is same. I hope that this concept got clear to you. Is it? Slowly we are learning the internal details of Python, how Python has been implemented. And now you are thinking from the designer's perspective. What I said is that my job here is not to teach you programming only, but it should be from a rediscovery point of view. Let's suppose many other undergrad people or the people who have here, they'll start, let's say they got interested in building a language. Now they know that what things are to be done, what design choices or what choices that we have to make. These are the choices that designers usually have to make. Okay, moving on. I'll just close this VS Code. So now these are the variables. Okay, so again, what you should do is the same thing is, once you saw something, you saw, let's suppose age, and then you saw some 50 over here, you should scan it from right to left. This is called as dry running of the code, and you should, in the head, you should make, and even when you are solving the question, it sometimes is very good to have a pen paper with you. When you are reading a code and you want to dry run, it's doing the same thing that I want. So you should take this, make an object 50 over here, and name it as age. Something like this. Okay, that's what you should do. And now Python also stores, it also allows multiple assignment. So this is called as single assignment. So you assign an object to a variable. Okay, that's called as assignment. Okay, in math, if you write, let's suppose x is equal x plus 1, this is not valid. But in programming, it's valid. So what will this do is, so let's suppose we have x is equal 20 for the first instruction. This will create an object 20, name it as x. And then it says x plus 1. So it will go to xc20 and it will add 1 to it. So it will make an object 21 over here. Okay, and then this x will be pointing over here. And then if you see this number is basically straight now. So it will be rather what's called as garbage collection. So it will be then collected by the garbage. Okay, there are garbage collectors also. So you saw the mechanism over here. Again, when you see an instruction, try to do it in this fashion, which I did. X is equal 20, create an object 20. Then x is equal x plus 1. What it does is go from right to left. See x plus 1. So you have the x and add this is 21. Make a new object. Then assign it to the x. So now you know that this x was actually over here. Okay, now you will basically just remove this name from this location and you will give to this location. Okay, now you have access. You do not have access to this memory location. So then garbage collector will come. It will collect this garbage. because this won't be used anywhere in the programming. Okay, there is a concept of pointers in C, C++, and so here we don't have that. So, but internally they are we're pointing, and there is something called concept of dangling pointers. Okay, so probably if for time permit we have a discussion on that. But this is how you should write you should read the code. So this is called as assignment. So if you have some object 20 and you write is equal to x, so what you will do is you will make the object 20 and you will assign to this x. Okay, that's called variable assignment. This is called a single variable assignment. Now you can also have multiple assignments. Let's suppose you made 3 variables a, comma b, comma c. Okay, and then you wrote 10, 20 and 30. Python allows this also. Okay, so what will happen is, so this a will be assigned to 10, this b will be assigned to 20, this c will be assigned to 30. C, again, ease of programming. I said the design philosophy is ease of programming. So here if you write probably this in C or C++ code, it will throw an error. Okay, and right, let's suppose we wrote a, b, c, and you can call it hello, first is string, and you can say b is equal some a, then b is equal to some 10, let's suppose, and then you can make a list 1, 2, 3. You can make this assignment also. So this is called as multiple assignment. Python does not care what programmers do, but if it is making a programmer's life easy, it will do that. Okay, so that's what Python does. So there is multiple assignment also, that's allowed in Python. You can do multiple assignment like this, a, comma b, comma c. These are 3 variables. And you know that Python is a dynamic language again. Dynamic means you don't have to mention data type. You don't have to mention the type of data. It'll see it from once the program is running, and it'll do the dynamic. It's called as dynamic allocation. We'll also learn about that. So, but here I want to make you understand that once you read a program, if you dry run the program, what should happen is that you should go from the right to left and see what objects to be created, and then Python scans the whole memory. If it is there, if the small numbers are there, it'll just see it, and after that it will probably assign that to the variable. And in Python also multiple variable assignments are also allowed. So I can just show you this ABC that we saw in the notebook. I'll just open the code window again. So here if you see, if I write something like this, ABC is equal to hello, 20 and 1, 2, 3. So the first thing is it's a string, here it is an integer, here this is a list. So now I can print all of these together. So you saw that hello, 20, 1, 2, 3. This is multiple assignment over here, and you can check the type of all these things. Now I said one more thing I said is Python is a dynamically typed language. So in the language like C, C++, if I export that, you write something like this, int C. You first mention the type. Okay, after that you do something, int C is equal to 10, something like this you will write. Okay, but in Python, so while you are, this is a dynamically casting language, so once you are done with the program, you don't mention the types. The program, the interpreter compile, they handle the type itself. Okay, you don't know, you need not to mention the types. Now from this we saw that each of these objects, each of this data, now the data that we hold, because this is data that we hold by using the variables, so it's of different types. So this data is of different types, they are called as data types. Okay, so with this we'll probably close the session. I'll just name the data and then probably I'll take the questions if there are some. So what I said is that each of this variable, each of this memory location holds some value. So the value can be of different types. Now the data can be of different types. Okay, in the real world also, if you see, things can be of different types. Some things can be made of concrete, some things can be made of iron. So there are different materials that are the things, different materials are used for different things. Similarly, this data is of different types. So you can use sometimes, let's suppose you need numbers. Okay, you need numbers, and sometimes you may need, let's suppose, alphabet or something like that. And within numbers also, let's suppose you may need decimal point numbers, you may need floating point numbers, or you may need integer. So all of these things are to be handled by the interpreter, or to be handled by the language, because for language everything is binary. Everything is binary. Now how you represent these things, that's why we have categorized these types of data. So the Python basically is a dynamically typed language. You need not to mention the data type, so it will determine dynamically at the runtime. So once you run the program, that time it determines that thing. Okay, so now this data type, there are different types. So what I can write is, I can say there are mainly 3-4 data types. The first thing is there are numeric data types. So in numeric we have numbers, we can have integer, float, double, whatever it is, and then we can have what's called as boolean. Okay, boolean data types. Then we have something called as sequence data types. Okay, and then we can say we have something called as dictionary data type. Dictionary. These are all data types. Okay, and we have set. Okay, within the set we have string. Within the sequence we have string. We have tuples. We have lists. What I want you to see over here is there are a lot of data types that are being handled by Python. So why is it necessary? Can I not do one thing? I'll just dump in the memory, and I say that's why I answer the question that each the type of the data, they have different operations to be done on them. So they support different operations. Let's suppose for this numeric data type, if we have integers, if we have floats and complex numbers. So here we have integer, we have float, we have complex numbers. In each of this type of data, they basically support different type of operations. That's why once you tell the computer that this is an integer, so in C0 you have a tell, but in Python it dynamically determines what is it based on the properties, and then it gives you access to the operations. So as you know that in the previous session also I showed you that this high plus 5, this is not valid, okay, because this string and this integer, we cannot use plus operation in between. This is not allowed, this is not defined by Python, but this is what Python has defined. This is perfectly valid in Python. So for each data type, because each data type basically is an object, this is I said this is everything that you create in Python is an object. So for each object there are supported operations, okay, and we'll have a detailed discussion on the data types, and then we'll start coding these things, and probably you will receive your assignments after that. I'll stop the recording over here. If somebody has questions, please feel free to ask.